Hello everyone, I welcome you all to yet another session wherein we discuss CAT level questions. So today I bring a geometry based question for all of you. So let's have a look at the question. You can pause the video for a while, give that question a try yourself, and then we'll discuss the question. Okay, let's start. So it says the lengths of two parallel chords are 50 centimeters and 120 centimeters. So there's one property that we have before we begin with the question itself. Let me just share that. So if you take a circle, you take a chord, let's say length of the chord is some d, center of the circle, let's say the radius is some r. Now there's a property that we have that if you drop a perpendicular from the center onto the chord, it bisects the chord. So that means this chord AB will be bisected if you drop a perpendicular. Also one more thing, if you say that this OX is some height h, now can I say this r, length of the chord, half the length actually, right, d by 2, and h are connected by Pythagorean triplet, the Pythagoras theorem, right, because you can say that r square will be equal to h square plus d by 2 the whole square, half the length of the chord square. Right? So that means h square, which is nothing but the distance between the chord and the center, can be calculated as, we are right now discussing in general term, I am just trying to share a small point and then we'll continue with the question, can be obtained as, h square can be obtained as r square minus d square by 4 or d by 2 whole square will be right. So thus h will be nothing but, I'll just write that down here in general terms, root over r square minus d by 2 the whole square. So this is your height or distance of the center from the chord, or distance of the chord from the center of the circle. Now after having understood this, let us continue with the question. So the two lengths of the chords given to us are 50 and 120. If the diameter of the circle is 130, that means radius is 65. Which of the following can be the distance in centimeter between the chords? See, look at the language of the question. He's asking you can be the distance. That means he's talking about a possible answer out of the many answers which are possible. Now, why are there many possibilities here? Please understand. Let's call this chord as AB, this chord as PQ, right? So the possible placement of AB and PQ could be like center, say this is PQ, 120 centimeters, and this is AB, 50 centimeters. So this way the distance between the two chords will be this. But another possibility could be PQ is here only, but AB is on the other side of the center. In this case, please understand the distance between the two chords will be longer than the previous case. So that means there are two different answers which are possible for the question which is being asked right now. That is why he uses the language can be. That is why the can be is used. Let's try to go for the question here. So R is 65. So for the first chord, let's call this as AB as I said. If AB is 50, what will be the distance from the center to the chord AB? Let's call it as H1. So can I say H1? There is nothing but distance between the center and the chord AB is nothing but given as root over R square minus D by 2, 50 by 2, 25 square. That's nothing but A square minus B square. A minus B, 40 into A plus B, we'll get as 90. So 40 into 90 is 3600. Square root of that is going to be 60. So that means in the circle, the distance between the center and the chord AB, wherever the chord AB is, wherever it could be, here or here or anywhere, this distance we get it as, the perpendicular distance we get it as 60 centimeters. So let's note this. So for this AB, the distance is 60. Okay, let's note this. Next, let's look at this chord. Let's call it as PQ. So if you do for PQ, the same thing that we did for AB, let's call the distance from the center to PQ as H2. So how much will be H2? Let's try to calculate. So PQ is 120. So H2 will be root over, again R is 65, so 65 square minus D by 2, 120 by 2 is 60 square. A square minus B square, A minus B 5 into A plus B is 125. So 5 into 125 is root 625, which is nothing but, I'll write it directly 25. So that means in case of second chord, the distance happens to be only 25 centimeters. So that means if I take the same circle, same center, but this time I am taking the chord PQ, distance from the center to the chord PQ, this distance is going to be 25. Okay. So H1 is known, H2 is known. Okay, 25. H1 is known, H2 is known. Now, as I said, there could be two possibilities for the placements of the chord. What are the two possibilities? Possibility number one, chord AB is above the center, chord PQ is below the center. Now, in this case, can I say this distance is 25 and this distance is 60? Hence, the distance between the two chords can be 60 plus 25. So, this is one of the possible answers, which is 85. Possibility number one. Possibility number two, center of the circle, this is your chord AB. Both the chords are on the same side of the center, like this, PQ. This distance we know is 25 and this distance, overall distance, we know is 60. So that means in this case, the distance between the chords is going to be difference of the two, H1, H2. So it can be 60 minus 25, which is nothing but 35. So that means we can have two possible answers for the given question, 35 or 60 or 85. Now let's look at the option choices. Which of the following can be the distance between the two chords? It can be either 85 or 35, but not 45. Thus, both is also not possible, and neither is also not possible because, of course, 85 is one of the possible answers. So, thus, the correct option choice will be option choice A for this question. So, I hope we are clear with the concept that we have used here, right, and the problem in itself. So, with that, we have come to the end of the video today, the question discussion today. For more such question discussions, please ensure that you subscribe to our channel. Please do share this video with your colleagues, with your peer group who are actually preparing for the MBA entrance examinations, so that they also benefit from this discussion. On that note, let me end the session here. Thank you and all the very best.